We're going to put A over the shorter leg from the blue triangle. So we'll make this our numerator, and this will be our denominator. What's the shorter leg in the blue triangle? X. So A over X equals shorter leg over shorter leg, and that's going to be the same as X in our red triangle over, what's the larger leg in the blue one? B. Now watch. If we were to solve for X, do you agree that we would cross multiply here? Yeah. So we would get X times X and A times B. So let's set it up. X times X equals A times B. You guys following me so far? Yeah. What is X times X? It's X squared, X to the second power, right? Equals AB. How would we finally solve for X here?
You would square it. You square both sides.
Don't square it.
I'm not divide it.
Nope, don't divide it.
Multiply.
Nope, don't multiply it. Square root. Take the square root of both sides. If we take the square root of both sides, do you agree that that squared is going to cancel with the square root? So we've just got X equals the square root of A times B. What does that look like? Does that look like that geometric mean thing that we learned earlier?
Yes.
Ah, correct. Okay? Yes. So whenever you guys are given an altitude and both those bottom segments, segment 1 times segment 2, multiply them, take the square root, that'll be your altitude. Okay? Yeah, Savannah?
Instead of because I was making baking last night, so I just multiplied A and B and square rooted.
Correct.
Doing all the.
I want to show you where it comes from, though.
Okay.
Like, they don't just pull it out of a hat, right? Now, for you, on like the test, if it gives you these 3 lengths, absolutely, just use the geometric mean.
Yeah.
You don't have to draw out the triangles or anything like that, okay? Now, if you forget what to do, you can always draw out the triangles and figure it out from there, okay?
Also, we don't have to take a whole bunch of A over X.
No. You could just set it up. Just make sure that you write out square root of those 2 multiplied together, okay? All right. There's also, you can apply the geometric mean theorem to the legs of your original figure, okay? So the length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So let's see where that comes from. Let's draw out our triangles again. And then the big one, which is like this. All right. So we've got, this is A, this is B, this is X, this is Y, and this is X, this is Y, and this is C.
And the big one, is that supposed to be the whole thing that's already there?
Over on the right? Yeah, this one's supposed to be the whole thing. The really, really big one.
A thing at the top?
Why is there a what at the top? Oh, a 90-degree mark? There should have been one up here. That's a good question. There should have been a 90 up here, because this has to be a right triangle in order for this to apply. Okay, part of our proportion is going to include the hypotenuse, okay? So, let's take the hypotenuse of the red triangle, okay? Which is what? X, right? So we're going to say X over, what's the hypotenuse of the biggest triangle? This one over here. It's C. Do you guys see that? Okay, so we're going to say X over C, C equals, and now the other side that we know is A, right? So we'll say A, which is the shorter leg, right? So we're going to say that equal to A over, what's the shorter leg of the big triangle? X. Do you see how it becomes a geometric mean again?
Yeah.
Because we're going to get X times X. Jaden, what's up?
You know how you're making the comparison to the big one, how come you don't do the small, the other side of it?
Okay, so that's a good question. So for this example, right, when it doesn't, like, we're not looking for the altitude, compare these two smaller triangles to the biggest one, okay? So this is a different scenario. Yeah, but that's a really good question.
If you're only asking for the altitude, then you do the two.
Correct. All right, let's do the same thing, but with the blue triangle, okay? So we're going to take the hypotenuse of the blue triangle, which is what? Y. So write Y over, what was the hypotenuse of the big triangle? C, right? So put Y over C equals, now B is the leg in the blue, in like the medium sized triangle, right? Is that the longer leg or the shorter leg?
Shorter. B is shorter, right?
B is longer, right? Do you see how B is like much longer than the other leg? Okay, so B is the longer one. And what's the longer leg in the biggest triangle? Y. Do you see how it's going to be a geometric mean again? Okay, so this one would be x squared equals a times c. In other words, x equals the square root of a times c. And in this one, it's going to be y squared equals c times b. In other words, y equals the square root of c times b.
So it can be either or.
Correct.
Okay.
Okay? All right, now watch. Let me explain this while looking at the diagram. So, if we're looking for the altitude, right? You take the geometric mean of A and B. Do you guys remember that? That was the first example we did. If we're trying to find this leg, X, we take the geometric mean of A times C, and then we take the square root. If we're trying to find Y, we take the geometric mean of B and C. Are you guys starting to see it a little bit?
Yeah.
So, what I want you guys to make the connection is if we're looking for X, right? We're going to use A and C. If we're looking for Y, we're going to use B and C. Do you guys see that? So if we're on the right side of our triangle, we're going to stay on the right. And if we're on the left side of our triangle, we're going to stay on the left. Okay? But you are going to use what value in all of them? C, right? All right. So let's check out some examples. Yeah. Do anything. Let's see an example. Okay? So go to example 3. It says that JR is 16 units, EJ is 9, and let's find HJ. So HJ is going to be this segment right here. All you need to do is take 9, multiply it by 16, and then take the square root. So HJ is going to equal 9 times 16 and take the square root of it. It's that simple. Okay, so HJ is going to be equal to 12. Because 9 times 16 should give you 143, 144, and then the square root of that is 12. Okay, that's when you don't know your altitude, but your hypotenuse, right, was cut into 2 equal parts, 9 and 16, or not equal parts, but 2 different parts, 9 and 16. That's when you take those 2 segments, multiply them by each other, and take the square root. Questions on that first example? Okay, so go back onto the next page, okay? Oh, go back. Take the square root of it, okay? So RH equals 16 times 25, and then we take the square root. You should get that RH equals 20, right? Use your calculators. Tell me if you get 20. Multiply 16 and 25 and then take the square root of it. You got 20? Perfect. All right, now, what if we were asked to find EH? We'll make this X. EH. It's going to be the geometric mean of what two values? 9 and 25. Do you guys see the difference here? Do you see how we're staying on the left side of our triangle? Okay, so now it's 9 and 25. So we're going to say EH equals 9 times 25, and then take the square root, and you should get 15.
I know that HJ is 12.
Okay, so that one, whenever you have the altitude, right, you do 9 times 16, the two segments, multiply them together, and then take the square root. So 9 times 16 gives us 144, and the square root of 144 is 12. Okay? So for each of these missing segments, you guys agree that you can use a geometric mean to find them? Okay, so that's why geometric mean was so important in this lesson. Jaden, what's up? HE?
Yeah.
Okay, so HE, right, which is this one?
Yeah.
It's going to be the geometric mean of 9 and 25.
Oh,
Okay?
It's on that side.
Correct.
So what's going to be the overall answer? Just when you go off of both of those?
So it'll ask you for any of these segments. So it might ask you for like EH, and you would just say EH equals 15. Okay? All right, let's do the exact same example, but with different things. So I want you guys to erase everything.
Can we just copy the page?
Or yeah, maybe copy it. That would probably be better. We know that this 2 is going to be the geometric mean of the square root of 4 times and then some value. We'll label it x. So now we have to do the reverse. What should we do? Because we're solving for x, right?
Yeah.
What should we do from here so we can start to solve for x? Square both sides. Okay? So square both sides. Right? What's 2 squared? 4 equals. And do you agree that this square root and this squared is going to cancel?
Yeah.
So now we've just got 4 times x. What do we do to solve for x now? Divide by 4. We divide by 4. So x equals 1. So this value is equal to 1. Now we've set up our entire problem, so now it's going to be really easy to solve. So we know ER, which is the full length of the hypotenuse, is going to be what? 5. So now EH, right? EH is going to be the geometric mean of what two values? 1, not 1 and 4. 1 and 5. Do you guys see it now? Okay, so EH is going to be 1 times 5 and take the square root. What's 1 times 5? 5. So EH equals the square root of 5. What's the square root of 5? 2.2.
Wait, what's R?
RH. We'll get to RH. Okay? And now the only thing that we're missing is RH, like Mariana said. Okay? So RH, remember, is going to be the geometric mean of what? Jaden? 4 and 5. Okay? So RH is going to be 4 times 5, and then do what with it? The square root. So it's going to be the square root of 20, right?
Oh, that.
So RH equals the square root of 20. What is it as a decimal? It should be like 4.8.
Yeah.
4.8? Perfect. Questions? Let's do one more example.
Mr. Yaku,
Yes.
I took the square root from 20 and I got 4.47.
Yeah,
Oh.
you rounded it.
So,
Oh, but then
it will go to 4.5.
it should be 4.5 then.
Wait, what? Wait, what? Why would it be 4.5?
If it's 4.48,
Oh, it was 4.4. Okay.
or 4.7, right? Then you round this one up to 4.5.
Oh, okay.
Okay? Problems, guys. You should have gotten that x is the geometric mean of what two values?
6 times 3.
6 times 3, right? So x is going to be equal to the square root of 18. In other words, x equals, what's the square root of 18, peeps? 4.2? Yep. How many people got that one? Let's go. Now for B, is it asking us for the altitude? No, it's asking us for this side over here. Did anyone set up the geometric mean the right way? Jaden?
See, I did y is equal to 2 times 7.
Good. Where'd you get 2 times 7 from?
Because 2 plus 5 is 7, and you have to find a small triangle. And then so you just did 2 times 7.
Good. This is our C value, which is equal to 2 plus 5, which gives us 7. So we multiply 2 and 7 together. We should get y is equal to the square root of 14. And then y is equal to, what is the square root of 14? 3.7. Yep. Yes.